So guys, good evening and welcome back to my YouTube channel at Teacher Ernest Mathematics. Today I'm going to take you through cubes and cube roots, and to be specific, I'll begin with cubes of numbers by multiplication. Let me just begin by cubes of numbers by multiplication. Let me confirm if the video is visible. Okay, it is visible. We can proceed. Now, in this cubes of numbers by multiplication, it is just a normal cubes. Remember, this one is a grade 9 mathematics. And then I'll begin with an example. And an example, I'll just begin with the simpler examples that says that find the cube. Let me just write here example 1. And before you proceed watching this video, guys, kindly subscribe to my channel so that and before you continue this video, subscribe to my channel so that I'll be able to bring you more videos about this mathematics grade 9, and also other forms. I'll be able to make some videos of the other senior secondary school of grade 10, form 3, form 4, and so forth. Also revising some of the NEC examination. I'll be able to do that one. So kindly subscribe first as before we proceed. So example 1, find the cube of each of the following. I'll have to touch all of them. This is example number 1. So here A, let me just begin with let's say 10. Find the cubes of the following. When they say that find the cubes of the following, this means that I'll be having 10 cube. What do I mean by 10 cube? Solution. 10 cube means that I take 10 and multiply 10 thrice. In this way, I multiply 10 times 10 times 10. The first 10 times 10 is 100. 100 times 10 become 1,000. If you have your calculator there, you'll be able to confirm that one. That's how you get that cube, the cube of 10. What about B? When I have when I have, let's say for example I have let's say 4, then they say that find the cube of each of the following. I'll have to write 4 cube. What do I mean by 4 cube? It is 4 times 4 times 4. You multiply 4 thrice. So this means that I'll be having 4 times 4 is 16. 16 times 4 is just 64. 64. Yes, you'll be able to get that answer. What if I have a decimal? If I have a decimal, let's say, for example, I have 1.2. 1.2, what will I get in 1.2? When you're told that multiply, find the cube of 1.2, I'll just write 1.2 cube. Then the next thing that I have to do is multiplying 1.2 thrice. 1.2 times 1.2 times 1.2. This is the same way as another person can write this one as 12 over 10, because when I take this decimal outside, I mean when I remove this decimal, it will be 12 over 10 times 12 times 12 over 10 times 12 over 10. This means that 12 times 12 is 144. 144 times 12, I'll be able to get 1728. I'll be able to get 1728. What about the denominator? I was multiplying the numerator, which is 12 times 12 times 12. 12 times 12, 144. 144 times 12, I'll be able to get 1728. Then 10 times 10 is 100. 100 times 10, I'll be able to get 1,000. Then when I bring the decimal inside by dividing by 1,000, this is how I bring the decimal inside. then I'll be able to get my answer as 1.728. You get it? So I hope you can be able to do this one. What if I have a fraction? What if I have a fraction, let's say part D, I have a fraction, for example, I take 2, let me just pick 2 over 3. 2 over 3. Then they said that find the cube of each of the following. 2 over 3, how will I do this one? I'll have to write 2 over 3. Then I introduce a bracket. Then I do what we call cubing. I cube. Then in general or in broader of this one, if I want to simplify this one or just evaluate, I'll have to write 2 over 3 times 2 over 3 times 2 over 3. Then after writing that one, I'll multiply the numerator. I find the cube of the numerator. This means that I have to take 2 times 2 times 2. 2 times 2 is 4. 4 times 2, I'll be able to get 8. What about 3 times 3 times 3? 3 times 3 is 9. 9 times 3 is 27. My answer is 8 all over 27. You underline your answer. What if I include another problem like a mixed fraction here? If I had a mixed fraction like 1 and 3 over 5, well, what am I supposed to do on this one? I have to convert into proper fraction such that I take, in fact, let me write the question first. I have not written the question. They say that find the cube of each of the following. I'll have to write 1 and 3 over 5. Then I do what we call a cube. It is difficult to do a cube of this one without converting into a proper fraction. So what I'll have to do, I'll have to convert to a proper fraction like 5 times 1 is 5. Then 5 plus 3, I'll be able to get 8 over 5. Then I close the bracket. Then I cube. After writing that one, what am I supposed to do next? I have to write, to expand, to open the bracket by doing this one. 8 over 5 times 8 over 5 times 8 over 5. So 8 times 8, I'll be able to get 64. When I take 64 times 8, I'll be able to get around 512. 512. What about 5 times 5 is 25. Then 25 times 5 is around 125. 125. If I take that one, then I'll have to divide. I have to simplify mean. 25 goes here once. You know, if you know, I know right now by this time round, for grade 9, you are supposed to be having your own calculator. But in this case, since I don't have a calculator, I'll know that 5 goes, 125 goes into 512 how many times? Around 4 times. Here 1, here 4 times. Then I'll be able to get 500. Then I'll be able to get around 500. Then the remainder will be 12. So what is the answer there? It is 4 and 12 over 125. That is what I'll be getting as the remainder, or the cube of 1 and 3 over 5. After doing all those problems, I believe that I'm done with the multiplication, cubes of numbers by multiplication. Let me proceed to finding the cubes of numbers from mathematical table. Cubes of numbers from mathematical table. Okay, with you, I believe that right now you should be having your own mathematical table. I'll have mine here. Before that, I'll have to explain to you how to use the mathematical table to find the cube of numbers. So when you in your mathematical table, you'll open up to a page where it is written cubes of numbers. This is the square root. I go to what we call cubes. Then in your when you reach in this table, you notice that this table is divided into 3 sections. The first section is the section that has the x on top. On top here, this column that has x, and the middle section is a section that runs from 0 to 9. That is the section that you're finding the cubes. Then the last section is what we called, the last section is called the mean difference. And on top here, it is written add. So it is running from 1 to 9. So let me just write an example. Then I show you how to find the cube. So example 1. It is example 2. Use table of cubes. Use tables of cubes to find the cubes of the following. Use tables of cubes to find the cubes of the following. Let me begin with the first one. The first one is 1.8. Then the second one is, let me pick B. Let me just pick B. A good example to be 0.697. And then C will be 195. Let me just pick a bigger value. 195.8. 195.8. My log table has fallen. Is it a log table? Okay. So, okay. Let me now open the table and show you how to find the cubes of those numbers. If you're told that find the cube of 1.8 from the table, I'll go to my table, and then on this table, it is visible, the camera. So I'll go to where there is in the column of x, then I'll go to where it is written 1.8. My 1.8 is here. Then since there is no preceding number after 8, I'll just read in the column of 0. Why? Because here the value of the next value after 8 is just 0 automatically, because there's no any other value apart from 8. So 1.8, I'll just go read 1.8 here, and then pick in the column of 0. I'll just read my value as 5.832. 5.832. The answer is 5.832. You can see the answer is in 4 figure, and that's why this table is called 4 figure, because the answer should be given in 4 figure. So what about 0.697? 0.697, when I come to my table here, you notice that in this table, there is the minimum value here that you can read from this table is 1.0. And here we have 0.69. So I have to write in standard form. And the standard form should be written in form of A times 10 raised to power n. This is how the standard form should be written in that. This is the form in which the standard form should have to be, or is supposed to be written. So for me to write the standard form, let me take 0, this decimal, into the number. So in short, I have the least number should be at least 1 plus. 1 plus. So that is the minimum value you're supposed to read from the table. So in this case, I have to write, when I take the decimal inside, I'll be able to get 6.97. And I told you that when the decimal is moving to the right, then the power should be a negative. So I'll have to write 10 times how many steps does that decimal moved. So the decimal have moved only just one step, one negative step. So I'll just write -1. Remember this one, we are finding the cube. So what I'll have to do, I'll find the cube. Even this one, we are finding the cube, but from the table. Then the next thing that I'm supposed to do here, I'm supposed to read this value from the table, and this value I have to read it direct to calculate direct using a calculator or just your mind. So in this case, let me read 6.9. 6.9. Here the maximum here is just 5.3. 5.3. Let me go to the next page that said cubes continue. Then I'll go to where it is written 6.9. Let me confirm it is 6.9 what? 6.97. I'll go up to this point, written 6.97. I hope it is visible, guys. Let me just shed some light so that it is visible. So it is 6.9. It's 6.9 but 7. 6.97. It is 338.6. It is 338.6 times. What is 10 raised to power -1? You cubed 10 raised to power -1. This 10 raised to power -1, 10 raised to power -1 times 3 times power 3, it means that I have to cube this one. So I'll take, when I open this bracket according to the laws of indices, you notice that -1 times 3, I'll be able to remove that power. So -1 times 3, it is just -3. And when a number is raised to a power, it means that that one is a reciprocal. That number is a reciprocal. So the reciprocal, it means it is supposed to be this way. 1 all over 10 raised to power 3. When I write 1 over 10 raised to power 3, it means that I do not include a negative this time round. Why? Because the negative here means the reciprocal. So, and when you have this one, 1 all over 10 raised to power 3. 1 all over 10 raised to power 3, it means that 1 over 10 raised to power 3, it means that I'm supposed to do 1 over 10 times 1 over 10 times 1 over 10. That is what I mean with that one. Because, okay, I'm supposed to include that. Okay, this one, I'm supposed to include the power 3 up there because it is affecting that number, the whole of that number. Even if you multiply 3, even if you cube 1 thrice, you notice that you'll be able to get the same answer as 1. So in this case, I'll be able to get 1 over 10, 1 times 1 over 10 times 1 over 10, I'll be able to get 1 over 1,000. So it is 1 over 1,000 here. So in this case, what am I supposed to get as the answer? When I multiply this whole number by this one, this decimal will take back this 0 will take back this decimal 1 negative step, then this 0 taking negative step, this 0 negative steps. What is the final answer? The final answer is 0.3386. That is our final answer. What about 195.8? 195.8. I want to read 195.8. Let me go to my table. You notice that 195 in the column of x, the minimum is 1. You can be able to read it in the column of x. And the maximum that you can be able to read here is 9.9. So it is impossible to read this one unless we change this into a standard form. And I told you that for us to change into standard form, the standard form is supposed to be a times 10 raised to power n. That is how the standard form should be written. So in this case, let me take the decimal. When I take the decimal here, you notice that I'll be able to get 19.58. 19.58 still is a huge number. You cannot be able to read in this table. The maximum number is 9.9. I'll have to take again the decimal one more positive steps backward. So in this case, my final value in standard form become 1.958 times 10 raised to number of steps that I moved. And remember, they are the positive steps. When you move to the left, you are making positive steps. When you move to the right, you are making negative steps. So I'm moving to the left. So I made 2 positive steps. Then after that, I do what we call cube, because we want to find the cube from the table. Then after that, I'll have to go to my table and read what we call 1.958. So I'll go to 1.9 is here, then 5. 1.95 is here. Let me just write that one as 7.41. I've just read up to this point, so my answer become 7.415. Then, but remember, I've not read this 8. So the 8 that is remaining, I must go to this column of adding. Then I proceed with this 1.95, 1.958, 1.9, then 5 in this column, then 8 in this column of adding. I'll be able to add 91. I'll be able to add 91 and check how I'm going to add. This is how I'm going to add. In this, when you are using for figure, the values that are in this add called this, how do we call this one? They are being called the mean difference. Values that are read from the mean difference column, they are being added. This is how they are being added. You must add them this way. 91. You just write them. They are guys. I want to find the cube of 27. When I come to 27, I'll just go and read here where there is 27. When I go here, it's 26. 27 is here. Well, it is written 27 0. So finding 27, I'll come and read in the column of X where it is coinciding with this 27 and take it is 3.0, 3.0. And where is 27? Where is the location of 27? 0 column. So it is 3.0, 0. So it is 3.0, then in the column of 0. My answer becomes 3.00. That is the answer to that, to the cube of 27. What about 10.82? 10.82, I'll go to where it is almost identical to this one, or a value that is near or next to 10.82. If I don't get the exact value, I'll pick a value that is next to 10.82 and should be below this 10.82. So 10.82, this is 10.6, 10.7, 10.794 is a value that is almost close to 10.82. I'll go and read where the row, I'll move with this row and read in the column of X. It is 2.2, but up to where? 2.21, because it is also coinciding with in the column of 1. So I'll have to read 2.21. So I'll have to write 2.21. But remember, we have got 10.7. We got 10.794, and we were supposed to get 10.82. We were supposed to get 10.82. So I have to subtract so that I see how to see which number is remaining, or to see the remainder so that it reaches 10.82. So here, if I subtract, I'll be able to get 6. This one is 1, and then this is 11. 11 minus 1, this is 26. So it means that 26 is the one that is remained so that it reaches 10.82. Then this 26, I'll have to go and also find it in the column of main difference, which is add column. In this section, add section, I'll just continue moving this 2.21 and then go to a value that is close to 26, but not exceeding 26. I'll pick 15 because 15 is close to 26. Then after knowing and noting that it is 15 that is close to 26, I'll find which top is what is coinciding with this 15. It is just 1. When I go to the top there, I notice that 1 is the one that is coinciding with this 15. So I just write it 1 here. This is the answer. What about 5,275? What about 5,275? I have to find it in the table. But you notice that when you come to this table, the highest value here is 997. It is 997. You hope you can be able to see 997 down here. Since it is not possible to get that one, I'll have to write in standard form. I'll have to write in standard form, and the standard form that I'm writing should be in the form of a times 10 raised to power n. That is in standard form. And after writing in standard form, when I'm moving the steps, when I'm moving in decimal, when I'm taking the decimal inside this number, I must make sure that I'm moving in multiples of 3. In multiples of 3 because I want to find the cube. I must make sure that I move in multiples, 3, how do we call them? This 91 is on the mantissa part, meaning that it's supposed to be 0.091, but we don't include them. For you to make your work easier, this is how you're supposed to add. Just add to the farthest end of this value. So when I take 5 plus 1, I'll be able to get 6. 1 plus 9, 10, 0 carry 1. Then I take 5.7. What about this one? Remember here I had 10 square, then I cube. It is 10 square, then I cube. What do I mean? When you, according to the laws of indices, 10 square, then you cube, it means that 2 times 3. 2 times 3 is how much? How many zeros? 2 times 3 is 10 raised to power 6. So I'll have to multiply times 10 raised to power 6. This is how we open that bracket according to the laws of indices. When there is a bracket in the powers, you just multiply the powers. Yeah. So in this case, the final answer here becomes what? Remember 10 raised to power 6 is just a million or a mega. Okay, 0. So this case I'll have to write 7.506 times a million. Then this 0 will take 0 outside. We take decimal outside. Then we are remaining with the 3 zeros. So by our final answer becomes 7506,000. That is our answer. So guys, I believe that now up to this point you can be able to handle question using a table. You can be able to handle question of cube using a table. Then let me proceed to what we called cube cube root. Is it cube root? I can proceed to cube root. And in finding the cube root, it is a very simple one, and we will begin with the finding cube root using factor method. Finding cube root using factor method. Let me just close this one. Let me proceed to the next one. Let me underline this way. Then we proceed as cube roots. Let me write here cube roots. Oh, it's not supposed to be written this way. It's supposed to be written as cube root. You have to separate these two words. There are two words. Good. Let me find now the cube roots. And under cube root, we will begin by finding cube roots of numbers by factor method. This one is the easiest method to use it to find the cube root. Let me just begin with an example so that I make your work simple. Example 3. Example 3. Use factor method. Use factor method to find the cube root. The cube root of, let me begin with this one. A, it is 729. 729. So in this case, by factor method, this is how we go about it. It is very simple, guys. Let me just write here. Let me begin on. I'll just write solution. 729 factor method. Let me begin with the least divisible number that can divide 729. If I begin with the 3, I notice that 3 goes to 7 how many times? 3 goes into 7 how many times? 2 times, remainder 1. Then 3 goes to 12 how many times? 4. And then 3 goes to 9 how many times? 3. Then I proceed again with 3. 3 goes to 24. How many times? 8 times. 3 goes to 3. How many times? 1 times. And then I proceed again. This is 3 again. 3 goes to 8. How many times? It is 2 times. Then I'll be able to get 6. 6 then minus 8. 8 minus 6 is 2. 21. 3 goes to 21. How many times? 7 times. Then again 3 here. 3 goes to 27. How many times? 9 times. Then 3 goes to 9. How many times? 3 times. Then, because we've been told that use factor method to find the cube root of 721. Cube root, from the word cube root. So I have to group the numbers into 3 groups. These are the way I've written them. I have to group them into 3s. Then in each 3s, I'll have to pick 1 3. In each 3s, I'll have to pick 1 3. So in this case, this is how I'm grouping. Because it is cube, I'll have to group them into 3. Then this one into 3. Then in the first group, I'll just pick 1 3. In the second group, I'll have to pick another 3. Then after writing that one, I'll have to say that the way I've said that I have picked 1 factors from each 3s. Then this one. So my answer here becomes 3 times 3, which is 9. So guys, when you take 9 cubes, you'll be able to get 729. So in this case, what do I mean? I mean that the cube root of 729, the cube root of 729 is what? Is 9. That's how we get using factor method. What about if I had a fraction? What about when if I had a fraction, like let's say for example, if I had, you've been told that use factor method to find the cube root, the cube root of, let's say 3 and 3 over 8. This is B. Find the cube root of that one. You notice that you cannot find it directly the way it is, but you have to expand. You have to find the proper fraction of this one. And the proper fraction of this one is like taking 8 times 3 is 24. 24 plus 3 is 27 all over 8. Then I find the cube root. Guys, never shall you write as this one. This is not the cube root. This is not the cube root. Why? Because this 3 is outside the root. This is how you are supposed to write the cube root. So make sure you are keen. So in this case now, let me factor out 27 and also factor out 8. If I factor out 27, I begin with 27. 3 goes to 27 9 times. 3 goes to 9 3 times. What about when I go to 8? The least number that can divide 8 is just 2. 2 goes to 8 how many times? 4 times. 2 goes to 4 how many times? 2 times. Then I'll have to find the cube root. The cube root of this first group, I'll have to group them into 3. Then I pick the one factor. Then also I group this one into 3. Then I pick one factor that is identical to all of them. Then after doing that one, I'll come to my problem, that was the cube root. The cube root of 27 over 8 is this way. I'm supposed to write. I'll have to write 3 all over 2. Why? Because the cube root of 27 is 3 and the cube root of 8 is 2. That is the answer. Hope you are getting something, guys, up to that point. What about when I had this one? If I had this one, if I had the p raised to power 6 and q raised to power 3, then I find the cube root. Guys, this one is very, very simple, guys. You can imagine how can we do this one. This is how we do it. I'll have to write the, when you see, when they have written, okay, this is a cube root, find the cube root by factor method. So this one, this is how it's supposed to be written, as p. Sometimes you can write in a factor form or you can just write in multiplication form. So the first one, p raised to power 6. P raised to power 6 is the same as writing p 6 times. P times p times p times p times p. You get it? The 1 2 3 4 5 times p again, so that they become 6 p's. Then after writing 6 p's, and I've been told to find the cube root, I'll group them into 3. This one I'll group them into 3. Then I just pick 1 p. Then I group this one again into 3. Then I pick 1 p. What about q? Q cube. It means that I have 3 q times q times q. Then I group also this one into 3. Then I just pick 1 q. What is the answer? Here, how many p's do I have? I have just p times p, which is p square. And this one I have q. I'll come and substitute here. So in general, sometimes you can ask, why have I separated this that way? You can write this way. You can write this way. Cube of p raised to power 6, q raised to power 3. Then you do this way. Since p and p is, okay, let me just expand it. P times P times P times P times P times P 1 2 3 4 5 6. Then I proceed times Q times Q times Q. Q, they are 3. So I'll have to group the P's, the identicals into three groups. So this one, I have to write that one, then pick just one P. In each three groups, then I just pick one P. Then this one, if I group it into threes, I just pick one Q. What is the answer? It is P times P times Q. That is what I mean with that one. Then P times P is P square. Q times Q. That is our answer, guys. You can imagine the way it is very simple, guys. Just very simple, very simple, very simple, very simple, very simple. Let me also proceed to the last part. The last part that I don't want to forget is finding the cube root from the table. Finding the cube root from the table. Finding the cube root from the mathematical table. Guys, this one is also very simple. Finding the cube root of numbers from mathematical table. This one is very simple, guys. Let me just pick an example so that I make it simple for you. Use table, example 4. Use table of cubes to find the cube root of, let me begin with this one, this simple one, which is 27. Then A is 27, B is 10.82, then C is, when we finish this one, it will be easier for us, 552, 75. So guys, stay tuned as I take you through this one. So in this case, guys, the first one, let me come with my table here. I go to the table of cubes. If make sure that I'm moving the multiple steps, three multiple steps, not even steps. Even steps is just for square root, but this one I have to move three multiple steps. So in this one, I move the first step, the second steps, and the third steps. So you must be moving multiple of 3 steps. Like the multiple of 3 is just 0, is just 3, and then also called 6, 9. Those are the multiples of 3. So in this case, after getting that one, I should get my answer as 5.275 times 10 raised to power what? Power 3 times 10 raised to power 3. Then after that, I'll be able to find the cube root. When I write these numbers raised to a third, this a third, it means it is a cube. It is a cube root, I mean a cube root. So this one, and maybe when I have when my n is a fraction, let's say a fraction, let's say it is a half, a third, a fourth. These are roots, guys. These are roots. Those are the one that I mean that they are roots. Then in this case, let me find now the cube root of this number from the table. I'll go to the table and try to read the number. I'll try to read the number as 5.275. I'll go to where there is 5.275. This is 4. This is 4. 4 still. 5 point something. 5.1. 5.268. 5.3. I'll pick a value that is next to 5.275, but not exceeding. So I'll pick this one, 5.268. When I pick 5.268, where is it? It is here. 5.268 is colliding in this row of 1.7 and coinciding with 4. So I'll have to pick 1.74. Let me write that one. It is 1.74. Then what am I getting here? I'm getting 5.268. Then I was supposed to get 5.275. What value is remaining so that I reach to 5.275? So this one, when I carry that one, I'll be able to get 7. So we are remaining with 7 so that we reach so that we get to reach to, is it 7, guys? 15 minus 8, it is 7. Yeah, good. It is 7. So when I get 7, then it means that when I go to this mean difference column, I notice that I'm not getting a value that is close to 5. That's one. A value that is close to 7. I'm getting a value that is exceeding 7, which is 9. When I get that value, it means that I'll not write this value. I'll just leave my answer the way it is. I'll just include just 0 because there's no value that is considering to get a value that is close to 7. It is only a value that is past 7. You see, guys? Then after getting that one, what am I supposed to do next? I'm supposed to find the cube root of 10 raised to power 3. I have 10 raised to power 3. And if I want to find the cube root, and I've told you that the cube root is written in fraction. So when I want to open this bracket, it will be 10 into 3 times a third. This a third will remove that 3 so that I remain with 10 raised to power 1. So my answer becomes times 10 raised to power 1. Times 10 raised to power 1. Times 10 raised to power 1. Then after getting times 10 raised to power 1, okay, sometimes I've seen something here. Sometimes since 9 is also close to 7, I can consider this one. I can consider 9 because it is not there is no big difference between 7 and 9. So I can just include that one and just write it here as 1. There's no problem. Then after writing this one, I'll be able to multiply 10 raised to power 1 times this one. I'll be able to get 17 because this 10 will be able to remove the decimal to the right so that I get 17.41 as my answer, guys. So since today I don't have much to say, but I can give you an assignment, guys, so that you go and test yourself and test if you can be able to find the cube root of the following. So exercise, evaluate the following. Evaluate the following using the table of cubes. Evaluate the following using the tables of cubes. Let me write for you. The first one here is the cube root of 478.4. Then the cube root B, the cube root of the cube root of 9700. So guys, those are the assignment. Kindly, if you have time, you can go through the assignment, and if you have any question, you can write in the comment section so that we discuss the question. Thank you guys for attending this lesson. Have a good day or a good evening wherever you are.